Good morning.
Morning.
Can you hear me well?
Yeah.
Can you see me?
Mm-hmm.
Excellent. What about my plan for today? I will continue with you working with graphs. And if we have more time after that, I will probably start talking about inverse trigonometric functions. If not, I will do that tomorrow. But before I start graphing, I would like to say a few words about our quiz. If you have any question about any of problems from your yesterday's quiz, you can address this question to me and I will go over any problem which needs your additional attention. So this is why please do not hesitate to ask me to go over any problem. We had only 4 problems. But it doesn't matter how many problems we have. If you have any question about any of these problems, please tell me about that. So I will quickly right now read your names, and after that we will go from there. So in first problem from your quiz, you were asked to find the values of certain function if value of one of functions and location of the angle was given. In this second problem, you were asked to find the exact value of the certain expression which had trigonometric function of the given angle. In problem number 3, you were asked to solve quite easy trigonometric equation. And in number 4, it was a trigonometric expression which you had to simplify. And again, I'm referring this question to all of you, ladies and gentlemen. And my question is, do you need any additional information, any feedback, or I can provide even full solution of any of these problems? Please think about that after I check your attendance. You will tell me about your decision. Is it okay with you?
Yeah.
Yeah.
Okay. So today is 21st of April, and I start reading. Andrew, Tima, Lorraine,
Here.
Lynn,
Here.
Juanita, Yuran,
Here.
Gabriel,
Here.
Divina,
Here.
Kobe, Chantal,
Here.
Gongsi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Nathan.
Here.
Yeah, I saw you. Your picture was first, which I saw. Okay, Alejandra.
Here.
Okay. Okay. What about your decision? What to do with our quiz problems?
Would you be
Guys,
able to go over the fourth question,
yes, I can.
please? Thank you.
This is simplifying the expression.
I believe so. It says chapter 9, section 9.2.
Just 1 second. Let me check. One more time. Section.
Section 9.2.
So
Question
no,
second.
this was not an expression. It was about solving equation. Okay.
Yeah,
Yes.
thank you.
Is this the one with the double angle?
With the double, yeah. Yes. Yes.
Okay.
Okay. Just let me grab a piece of paper. Again, as you are aware, you can have slightly different problems. The nature of the problem is the same, but they can be arranged in some different ways. In other words, they can be slightly different. I'm going to read this problem, which I grabbed similar problem from the textbook, so you can look at this problem. And it was like the problem number 35 from 9.2, which is on page 364. And what should we do here? We should solve exactly the following equation. Sine of 2 theta minus cosine of theta equals to 0. But we should not find the formula for the general family of solutions. We need to solve this for theta, which belongs only to the first revolution. Does it look familiar? This is what you wanted to go over?
Yeah.
Okay. So this is a trigonometric equation. Our unknown is theta. But we can ask ourselves certain questions, as we usually do, solving this type of equations. Do we have same angles in that equation?
Yes.
No, because one angle is theta, the other one is 2 theta. We not only have different angles, if we ask ourselves the second question about same functions or not, and functions are different, angles are different, and functions are different, which is not good so far for us. What can we do? We can use certain trigonometric formulas, if we have them, to make angles same. They should match. And after that, or maybe together with that step in the same one step, we can make angles matching, and we can get matching functions. So which is the smaller angle? Is it theta?
Yes.
Sine of 2 theta, can I say that it is a sine of a double angle?
Yes.
Yeah.
Do we have in trigonometry any formula for the sine of the double angle?
Yes, we do.
And one of easy formulas is sine of 2 theta equals to what?
2 sine theta over times cosine theta.
Right, I already wrote it down. Sine of 2 theta equals to 2 sine theta times cosine theta. And it is very beneficial to use that formula, because can you see now we're getting angles which are matching what we had in the equation already? It is now theta instead of 2 theta.
Yes.
Can you see that one of functions is also matching that one which we already had? So, conclusion, using that formula, which I am boxing, let's replace sine of 2 theta by what it is equal to. It is equal to the product of 2 and each of these trigonometric functions sine theta and cosine theta. This now what we have, 2 sine theta cosine theta minus cosine theta equals to 0. And now we continue. What would you do? What would you do if you had in algebra the following equation? 2ab minus b equal to 0. Would you factor b out?
Yes.
The role of that b in our equation, place cosine theta. Factor cosine theta out. What is left? 2 sine theta minus 1 in parentheses equal to 0. So far, so good?
Yeah.
Yes.
Can we apply zero factor property, breaking this into 2 easy equations? Ladies and gentlemen, I asked you a question. Can we apply here a zero factor property?
Yes.
And look what we are getting now. Instead of given equation, which we had, now we have 2 easy looking equations. And now let's solve each of these. In the first equation, cosine is equal to 0. In the unit trigonometric circle, we have only 2 angles which have cosine equal to 0 in one revolution, in the first revolution. So it will be 90 degrees, or interval was given in radians. This is why I am showing this in radians. Theta 1 equals to pi over 2. And now I am moving to another angle. Another angle is 3 pi over 2, which is theta 2. And I not only wrote them down, I showed them on this circle. Pi over 2 and 3 pi over 2 in one revolution, which is being represented by the given interval. We do not have any other angle for which cosine will be equal to 0. Did it click?
Yes.
Can I move to the second equation, part B?
Yeah.
This time, it is 2 sine theta minus 1 equal to 0. My goal right now is to solve it for sine theta. And after I have the value of the sine theta, I will be using that unit trigonometric circle to find theta. Okay. 2 sine theta equals to 1. I moved -1 to the other side, changing the sign. From where I'm getting sine theta equal to 1/2 after dividing both sides by 2. I will sketch right now another unit trigonometric circle. I remember that in the unit trigonometric circle, sine of any angle is equal to the y coordinate of the endpoint on the terminal side. This y in this circle, I'm looking for the value of y equal to 1/2. It is right in the middle between y equal to 0 and y equal to 1, midpoint on the radius. After that, I will be sketching a perpendicular through that point so that it will cross that circle at 2 points. These 2 points on the circle are endpoints of these terminal sides of possible angles. I'm going to connect these points with the center of the circle. I'm getting 2 radii. These 2 radii are representing the terminal sides for each of these angles, and I'm going to use small arcs to show that angles. One angle, as you can see, is from the first quadrant. Second angle is from the second quadrant. And I know that sine should be equal to positive 1/2. And I know that in the first quadrant, in the second quadrant, sine is positive. So far, everything is perfect. And now, I'm going to write answers. First angle here is from the first quadrant. So it will be theta number 3. In the first quadrant, which angle has sine equal to positive 1/2? Guys, I asked you a very easy question.
5 pi over 6.
It will be pi over 6. Now let's find the other one, which is in the second quadrant. Can I say that the second angle is pi minus that certain angle? And this certain angle has what kind of measure? Pi over 6.
Pi over 6.
Yes, definitely. So it will be pi minus pi over 6. If you subtract pi over 6 from pi, you are getting 5 pi over 6. Let's see. We can look even at these circles. Let's decide if we need to accept all 4 values. Are they all 4 angles from the first revolution?
Yes.
Yes.
That's it. So solution set. You can list them in any order, but definitely if you are doing this in ascending order, starting with the lowest angle and going to the largest, it will look quite elegant mathematically. So the smallest angle here is pi over 6. So I'm just listing pi over 6, comma. The next angle, which you can see, is pi over 2. Finally, we have 5 pi over 6 and 3 pi over 2, the last one, the largest. So, and solution set is right there in this set brackets, pi over 6, comma, pi over 2, comma, 5 pi over 6, and finally 3 pi over 2. And we are completely done with this problem. Are you satisfied?
Yeah, thank you.
You're welcome. Do you need any additional feedback? Okay, can I start talking about graphs again?
Yeah.
Yes.
Okay, so thank you. Let me remove this. And show the last problem, which we started, but we did not have enough time to finish. Let me show this to you. This is problem number 4. Do you recognize that problem which we had yesterday?
Yes.
Yeah.
And I hope you wrote down also the values of all parameters. Did you?
Yes.
And according to these parameters here on the side, I already listed some formulas, or excuse me, some properties. Look what we have. Domain is set R. Amplitude is 2, because I'm just using these results, which we went over right here. Vertical shift is -1, or if you like, 1 unit up. And look how I built our range. I showed this in the process. If we do not have vertical shift, the range will be, using the information about amplitude, from -2 to +2. But because we need to consider that we have a vertical shift 1 unit down, look what I do. I subtract 1 from each end of that interval from -2 to +2. And I'm coming to another segment. It is range equal to segment -3, 1, because I shifted that segment from -2 to +2, 1 unit down. So period is pi, phase shift is plus pi/4, or if you like, pi/4 units to the right. Midline has an equation, y equals to -1. Do you have questions about these properties?
No.
Excellent. But look what I'm going to do. Look at another formula with the number 4 star. It is right here, 4 star. And tell me if it is a relative, or I can even say close relative of equation in part 4. Y equals to -2 cosine of 2x. Does it remind you a little bit formula in part for equation in part 4?
Yes.
The only difference here is C is 0 and K is equal to 0, right?
Yes.
So which means it has same A value, which is -2. It has same omega value, which is 2. And this is a formula which is a very close relative of the original equation, form of original function given by original equation. Why? They are sharing, again, same A value and same omega value. This why both functions, first, they will have same domain, they will have same amplitude, and they will have same period. This why I can first sketch the graph of the function given by the formula in 4 with the star, because it is much easier to sketch that graph. The range for that function in 4 star, there will be a segment from -2 to +2, because amplitude is 2. Because it has A equal to the negative number, this I prepared for you. This dashed graph represents the graph of that function given by the equation of y equal to -2 cosine of 2x. You can see the midline of that graph is y equal to 0 line. In other words, it is our x-axis. And at the origin, the value for x equal to 0, the value is -2. it reaches its minimum. If we had here positive 2 cosine of 2x, that at that point on y-axis, we will be having a maximum. It will be, instead of 0.0 negative 2, it will have a 0.0 positive 2. But because it is negative at 0, x equal to 0, we have a minimum for that graph. Can you please sketch this graph? You can use different colors, or you can use dashed form of the graph as I did. And I showed this graph in 2 cycles. So far, so good?
Yes.
Yes.
Now, I am going to use that important points, which I'm showing here by dots of this graph, and I will be shifting them. I will be shifting them, how? Pi over 4 units to the right and 1 unit down, as we had in original equation for original function, because we had phase shift or horizontal shift, pi over 4 units to the right and 1 unit down. Please, let's do that. If I were you, I would probably sketch another set of horizontal lines through 1 and through -2, because the point on y-axis 2 also comes down 1 unit. So it will be much easier. Again, if you are using graph papers, it is not a necessity, but if you don't, it will be nice to show limits for that graph. And if you look at the labels on x-axis, you can discover pi over 4 spot, and this means that this interval shows you the length of pi over 4. So let's start. The most left point, it will slide from -pi over 4 horizontally to -3 pi over 4 and 1 unit down. So this is the new location of that point. The other point was on the x-axis. So from here, from -pi over 4, it would slide again pi over 4 units to the right to -pi over 2 and 1 unit down to reach -1 level vertically. I hope you see that dot, which is right there, right here. So practically, I already have, and I am showing that wave right here, solid one. After that, I move to the top point right here. Oops, this one. And it will slide also pi over 4 units to the right, 1 unit down. And I already have another solid part of the graph. And I will continue in the same way. Each time moving each significant point pi over 4 units to the right, 1 unit down. And so on. Each one, please, in the same way. and I got a graph of that function. To label it, I will show the arrow and I will write down y equals -2 cosine brackets 2 x minus pi over 4 bracket minus 1. So practically I used a dashed graph because this graph was much easier to sketch. And after that, I used phase shift and vertical shift to get desired graph for our original function. This is a very common strategy to build these graphs. Can I move to another problem?
Yes.
Yes.
Okay. I'm going to use problems right now from your textbook. And in many cases, we will be using already graphs to determine certain properties, which you have in your homework assignments as well. Let's say this is section number 7.4, and I'm on page 290. We have here at the bottom of that page, we have two problems, 7 and 8. Again, this is from section 7.4. It is on page number 290 in your textbook. So I'm not going to sketch these graphs because they are provided in the textbook, but I'm going to read their request. Determine the amplitude and midline of the periodic function and whether its graph is a vertical stretch and slash or shift of the graph of y equal to sine t or y equals to cosine t. Let's look first at problem number 7. Problem number 7 is in your textbook. This is the problem number 7. You can see, oops, the entire graph is above x-axis. What is the meaning of that? This is a sinusoid. If we do not have vertical shift, the midline will be represented by the x-axis, which has an equation y is equal to 0. Entire graph is above that x-axis. And can you see that midline of that particular graph is y equal to 1? Guys, can you please work with me? Hello?
Yes.
Can I say that midline is above and it is from 1? Can I say that it is y equal to 1?
Yeah.
No.
Yeah.
Can I
Well-
say, can I say that it is y equal to 5?
No.
No.
Because entire graph actually fluctuates between 1 and 5. Is it y equal to 3?
Yeah.
Yes, it is y is equal to 3. So does it mean that if we talk about modified formula covering entire family, that it means that it has a vertical shift, and vertical shift is affiliated with k, so it is k equal to 3?
Yes.
In this case, can we actually answer one of questions, because it is also about vertical shift, that we have a vertical shift? 3 units up or plus 3 if you like?
Mhm.
Yes?
Yes.
Yes.
Now, in your opinion, what would be entire height of the graph? Is it between 1 and 5 vertically?
Yeah.
How can you find the height of the graph? Is it 5 minus 1? Guys,
Yes.
how tall this graph is total between lowest point and the highest? Is it 4 units?
Yes.
Yes.
What about amplitude? Is it a half of the height?
Yeah.
Yes.
Is it 2?
Yes.
Yes.
This is what I'm writing. I'm doing this little by little, saying height is 4 units, amplitude is 2. But amplitude is absolute value of A. Absolute value of A. So, which means we can have two options in general. We can have A equal to positive 2. We can have A equal to negative 2. Is it correct?
Yes.
Mhm.
Because for both numbers, absolute value will be 2. So, but we need to choose right now one of options, or positive 2 for A or negative 2 for A. Next. So what do we see here? At this point, which is 0, 3, this is exactly on the midline of that graph. Is it passing through the point 0, 3? Guys.
Yeah.
What about this point 0.3? If the vertical shift is 3 units up, it means that this is a new location instead of the origin. Origin moved 3 units up to 0.3 level. And this, the graph which is passing through the origin being lifted 3 units up. Do you affiliate this graph with sine family or cosine family? If there is no vertical shift, which family actually was running through the origin? Members of sine family or cosine?
Sine.
Sine. So which means, look what we have. And besides that, it is already member of the sine family. So it is affiliated with sine. Now, besides that, it is lifted, vertical shift. Now, if you go from y-axis to the right, that graph, is it moving up and after that down, or down and after that up?
Going up.
Going up. It can happen when A as a coefficient in front of sine is positive or negative?
Positive.
Only positive. So which means, yeah, in general, we had two options. A for this amplitude could be positive 2, it can be negative 2, but we eliminate A equal to negative 2, and we are left only with positive 2. I don't think that you see here possible phase shift. So I can go an extra mile because I actually can write right now the formula for this particular function, because I can find a period as well. You need to find the similar points, because similar here, what? The graph goes up and after that it moves down and after that it comes back to the midline. This is one full cycle. And after that we have the second cycle, which again starts with the midline, goes up, after that moves down, down to its minimum and comes back to the midline. So basically here, the period, this cycle has a length equal to 1 period. So this period here is 2 pi. Period is equal to 2 pi. It can happen only if omega, a coefficient in for x, under formula symbol of sine is 1. That's it. The formula for that particular function, they are not even asking about the formula because I went an extra mile. They asked me to determine the amplitude. We did. Amplitude is 2. We answered that question. Amplitude is 2. We answered that question a long time ago. That we went an extra mile, and we know that actually a coefficient having amplitude is equal to should be positive 2. And midline of the periodic function, yes, midline is y equal to 3. We also answered that question. And whether the graph is on the vertical stretch. Do we have a vertical stretch? What is the total height? Is it 4 units?
Yeah.
We have a stretch. It was stretched 2 times vertically, stretched, because this function has greater height than the function without stretch. The function without stretch amplitude is 1, and the total height will be 2 units. This height is 2 times greater. Yes, we have a vertical stretch. And I'm ready to write down the formula. 2 sine of x plus 3. Again, they did not ask us about that. The space is quite crowded here. I hope you can see I wrote it right here in the box, right here. Y is equal to 2 sine x plus 3. Because again, I did it purposely, actually showing you more information about that function. Let's look at problem number 8. I need to grab another piece of paper because I don't have space here anymore. Just 1 second. Same page, page 290, and problem number 8. In problem number 8, we have another graph. Again, please look at your, this is right here, problem number 8. Graph is provided. And this time, what you see here is dashed horizontal line. Is it passing through y equal to -1?
Yes.
Yeah.
So which means here we have a vertical shift 1 unit down, or -1. Okay, now, what about total height of the graph? Can you see the highest points, they reach the level of y equal to 4?
Yes.
And
Yeah.
the lowest points, minimums, they reach -6 vertically?
Yes.
Yes.
Is it actually it actually means that a range here is from -6 to 4?
Yes.
What is the height of that? It is 4 minus -6. Is it height equal to 10 units?
Yes.
Yes.
Do you remember that amplitude is half of the height? So we have vertical shift, and amplitude is equal to 5 because it is half of the height, right?
Yes.
Yeah.
So do we have a vertical stretch? What is the total height? Is it 10?
Yes.
What should be for basic function? Is it 2 units? because amplitude will be 1 for the basic, y equal to sine theta or cosine t. Yes?
Yeah.
Mhm.
Excellent. So which means, yes, we have a vertical stretch. It was stretched 5 times vertically because regular amplitude should be 1. This amplitude is 5. So 5 is 5 times greater than 1. It is stretched 5 times vertically. Yes, write it down. But amplitude equal to 5 can have 2 versions. A can be 5, A can be -5. Now, what happened with this graph? Because midline, instead of being x-axis, which has y equal to 0 equation, it moved to y equal to -1. Right? And look how it runs on the right side. If we do not have that vertical shift 1 unit down, it will be at 5. It will be running between -5 and +5, having same height, 10 units. Is it at x equal to 0? This graph, does it have maximum or minimum, or it runs through the new position of the origin?
Maximum.
Maximum. In this case, is it a member of cosine family or sine family?
Cosine.
Cosine family. Should it have positive A coefficient in front of cosine or negative? You just said it had a maximum.
Positive.
Right. So your A, again, we're going to have extra mile. Cross out negative. We don't need negative. So what is the period for that function? Again, because I will be writing down the formula.
2
Find
pi.
similar points. Is it 2 pi?
Yes.
Period is 2 pi. What is the meaning of that? It means omega, which is the coefficient inside of the formula for x, is 1. I am ready to provide right now a formula for that particular function. So y equals +5. It is definitely member of the cosine family. Omega is 1, so it will be cosine of t. It had vertical shift 1 unit down, and I have a formula for that particular graph. Again, they did not ask us to find the formula, but I, again, went in an extra mile to show that information. There are other quite interesting problems. On page number 198, similar to what we already did, there are several graphs where you can see graphs. All graphs are waves. They are sinusoid. They can be graphs of sine or cosine families. And in this case, you can analyze all these graphs using absolutely same approach as we used right now. And again, I am right now on page 298, and maybe I will have time quickly to do one of these problems short. Oh yes, I can do quite easy one. Problems from 1 through 4 state the period, amplitude, and midline. Perfect. Let's say problem number 4. Problem number 4 is y equals pi times cosine 2t plus 4 minus 1. Pi cosine parenthesis 2t plus 4 minus 1. I can find even more information, not just about period, amplitude, and midline. Look what you have to do in this case. If inside of parentheses, your coefficient for t is not 1, immediately factor it out. So 2 should be out, and rewrite your formula in better form. Pi cosine 2 times parenthesis t plus 2 minus 1, please. And now we can find everything what they asked us about. Looking at this formula, I can recognize values of all parameters. Is it true that A equal to pi? Omega is equal to 2. C is equal to 2. And K is equal to -1.
Yes.
Right? And now
Yes.
I'm going to use the values of each of these parameters to give additional interpretation. A is equal to pi. Does it mean that amplitude, which is absolute value of pi, is pi?
Yes.
Omega is 2, and this is cosine family. So period equals 2 pi over omega, which is 2 pi over 2. Period is also pi.
Yes.
C is equal to +2. They did not ask us about that. Again, we go an extra mile. Does it mean that phase shift here is equal to negative, excuse me, my alarm. Is it -2?
Yes.
Guys,
Or 2 to the left.
because it is in opposite direction, -2, or 2 units to the left. K is equal to 1. Does it mean that vertical shift is -1 or 1 unit down?
Yes.
Midline, is it y equal to -1?
Yes.
So they actually asked us only about what? The period. Period is, I'm going to box what they asked us about. Period is pi. Amplitude is pi. And midline is y equal to -1. Again, if under symbol of trigonometric functions in parentheses, coefficient for your variable is not 1, factor it out. Even if I had here -2t plus 4, I would factor -2 out. And after that, I would use the property of cosine. It is one of even functions. I would drop this minus and I will get the same, only in same practically formula, only in parentheses instead of t plus 2, it will be t minus 2. It will have a different phase shift. The rest will be the same. I hope you refreshed some of your old memories about these functions, because in trigonometry class, you actually covered many of them. Can I end my session right now?
Yes.
Okay. So tomorrow I will have office hours. So if you need any additional feedback from trigonometry, please, I invite you, visit me and we will discuss. Everyone have a nice, beautiful day. Okay? Bye.